Going on, guys? I hope everybody's having a good Monday. In this video, I'm going to show you how you can add this robot to your game. So in the last video, we added this effect where if you fall off the edge of the map or the edge in like a hole or anything like that inside of your game, your screen will pixelate and your character will like teleport above the map, and then it will repixelate while you're falling until you land. And these robots that we've added, they don't actually directly do damage, so they're going to go along with that effect that we added. So if you get hit by a robot, it just pushes you. So as long as you stay on the actual ground, you're fine. But if you fall into the hole, then you take damage and you teleport above the room. We're going to be just adding the robot itself, and I'm going to keep handling the script. If you guys want a video, like a Blender video on how to make the robot, definitely leave a comment in the description of the video. There's some things that we added, like these lights. That's all done through like a code, and like all the materials, we've added those as well. I'm going to go over that. And then like this whole like bouncing between these 2 points, I'm going to show you how I set that up. And there's actually some points on the ground, so you can't see them. So let me just turn them on again. So I've created these points, right? And what you can do is, because you can reuse this robot in any of your rooms, you can put the points anywhere and it will go between, it will go between the points wherever you put them. So like, let's say you move this right here. Let's just move it like here. This is probably going to crash into the other one. Oh, let me just put it here. So it will go between the 2 points. So wherever you put them inside of the room is where it will like kind of go between. So let's unpause it for now and let's see. So you can see that like he'll walk in between, and they just kind of crash into each other, but he'll walk between the points that are on the ground. So you could like put those points anywhere, and he just basically patrols between the points. And if he hits you, he sends you completely flying. And then if you fall, you take damage, and then you can die. So it's quite a cool monster to add to the game. If you guys are enjoying my series, make sure you like the video and subscribe to the channel. Like I said, the entire project and this model, everything's available for download in the description for free. And yeah. Okay, so here we are in the starting room, and this is the same concept as all the other rooms that we made. So I made a video on how to make a room, like a brick room, and the only difference is inside of Blender, you can see that I cut away some of the bricks. It's the same thing, but you would just select some bricks from the walls and just delete them. It gives it like the kind of like broken down effect. All right, so in the description of the video, there's going to be a package file that you can use to get all of the things that you need to make the robot zombie work. So that file looks like this. So if you double click on the file, you get a screen that looks like this one. Now mine doesn't show the checkbox for materials or quick outline because I already have these in my project. But the only thing that is not showing is metal because I just changed this. But if you press import here, you should get all of these should import themselves. And then you should have a folder that looks like this one. And basically what you can do is if you drag this robot zombie, this is called a prefab, you can drag it from the bottom and you can place it in your scene like this. And then that's pretty much it. And it should just work by default. You can see that these little dots are here, so you have to move them around to configure the path. If you click on the robot zombie, there's a bunch of settings for him. So this is the container for the zombie, and this is the zombie himself, because these 2 points are part of the prefab. And if you move him and the points at the same time, then he will, as he goes towards the points, they'll move and it will mess up like the path, right? So that's why there's an outer layer to this game object. Yeah, so there's a bunch of settings here on the right. Let's open the script and I'll just go over. So all of these things at the top are called variables, and we're setting them up in the inspector on the right. So I'm going to go through them in the inspector, but this is where we set them up in the script, I guess. So if you click on this and let's hit play, and I'll have to disable the start room because, so when my game starts, there's something called the start room and that gets enabled. So that's why that was happening. But so these are the settings here on the right. So point A is one of the points where he's walking to. Point B is the other point, obviously. Hop height is how high he hops. So you can turn this up. Now, something to note is if you turn this up, you need to adjust his location because he is exactly centered. So before he starts going, you need to make sure that he's the right height off the ground. It's using sine, so it's I would just leave it or like keep it a number. Don't turn it up to 11, obviously. I think I fucked him up. Hang on, let's restart. Okay, so then there's also the hop frequency. So this is how often he's hopping. So you could like make him into like a fucking blender if you want to. Looks like a lot of these settings, if you change it while it's running, it breaks it. So then there's the move speed. So this is pretty obvious what it does. So if you wanted to like can increase the hop frequency and then like have him go like across really fast. So I mean, this kind of thing makes it harder to dodge him, so you can't really see the bouncing as much. Maybe we'll turn up the frequency more. Yeah, perfect. Okay, and then yeah, so let's okay, the stop duration is how long he stops before he turns around. So you could put this to like 0.1 and he'll just immediately turn around when he gets to the end. The cycle time is how fast the light cycle. So let me slow him back down to like 50 or something. And we'll make this 20 or 16 or whatever it was. So the cycle time, again, that's how fast these lights are cycling. So every second they're cycling. So if you make this faster, they'll go. Oh, no. That's a time in milliseconds. So the lower the time, the faster they'll cycle. So if you put this to like 0.1, which I think it was already, you could see that it's flickering now. I don't know if you can see that, but if you look on the back of him, the lights are now flickering really fast. So I like having it at a lower number. The brightness multiplier, this is how bright the lights are. So you could turn it up to like 50 or 500. So you can see that they're way, way brighter now. And this uses like the emission. So let's just change it back. That's too bright. Oops, I pressed Control Z and now he's not moving. Cool. Okay. So yeah, so then there's something called the distance threshold. So when he gets to the point, he needs like he'll never get to exactly the destination. This is how far away from the point that he can get before he'll start turning around. So like there's like a threshold that it's like the distance between him and the point is if it becomes less than 0.5, then he'll start turning around. He doesn't actually try to get exactly to the point because in Unity, he'll never do that. So even if you like move your object towards a point, it won't ever get exactly to the point. And there's a lot of factors like he has a box collider that pushes him off the ground. So if this point is too low to the ground, then the distance threshold will prevent him from like, I don't know, needing to exactly get to the point, I guess. The rotation speed, this is obviously how fast he turns when he gets to the end. So let's put that back up to 500. So the hop distance threshold, this is a number that, this is the distance from the point where he'll stop hopping so that when he gets to the point, he doesn't jump up and down once on this spot while he's like rotating. It's kind of hard to explain. This prevents him from having an awkward interaction. So like, let's say you're bouncing between these points, right? And you bounce like this, and then you land like right in front of here. Well, you don't want him to start bouncing like over this way because this is the max spot that he can go to. So this is the threshold that will prevent him from bouncing extra, I guess. It's kind of hard to explain, but it's just like a hop distance threshold is like, it prevents him from like doing an extra bounce at the end when he gets here so that he just stays in the spot and then he goes back. It would probably be better. It doesn't look like he's on the ground when he gets to the end. Let me see. Oh yeah, he is. And the entire time, I have these wheels on him as well. Okay, it looks like he's under the ground there. I have wheels on him as well. I didn't end up using the wheels because it's a top-down game and you can't actually see the wheels. So I did animate them in Blender, but I just thought that it was a waste of time to actually make them roll because from our game view, you can't see them at all. And this is also kind of why I made him hop, because it doesn't look like he has anything moving him otherwise. It just looks like he's just like floating or something, which I mean, it's kind of cool. It's a robot, so it kind of makes sense. But yeah, so these are all of the settings. Hopefully I explained them adequately. The three lights are obviously the lights on the back. You're just inputting them for the script or whatever. But okay, I'm just going to start with like the important information in the script. So this is the script that we're using to do this. This is a very, very complicated script. I don't expect that most people watching this will understand. So if you copy like these settings are kind of what matters. You can edit the settings on the right and away you go, right? But for people that are a little bit more technical and they're more into this, I'm going to try to go through some of like the settings and how I set this up. One thing to note is that at the bottom here, we're using on collision enter and we're using my character. So if you're trying to import this this model into your game, you're not going to have a stick wizard and you're not going to have this impact receiver script probably. This is very specific to my game. This adds force onto a character controller. So if your character is not using a character controller, you could use a rigid body and add force. Or if otherwise, you just need to delete this and set up your own on collision enter. Maybe you make it do damage. Maybe you make it do whatever. Obviously, I can't add that into the video because I don't know how your health for your character is set up and stuff like that. So yeah, so in the start method, we're starting 3 separate coroutines, and these are kind of named as what they do. So update emissions routine. This updates the lights. So like the 3 lights are toggling between each other. Moving between the points is just the moving between the points. And then the hopping is a separate coroutine. So moving and hopping are actually 2 separate coroutines. It's very difficult to make the robot land exactly, like you would have to do some type of math to calculate how many bounces he would need to get to the other thing. I'm sure that I could set that up or I could like figure that out, but that's way more complicated. And because this is the top-down game, you really can't tell. So like when you're playing, you don't you don't know. At the end, he might be floating here, but you don't really see that, and we're just using sine to make him go up and down. But if we wanted to actually calculate how many hops, we'd have to probably do a bunch of... Oh, I'm stuck. I'm going to fall. But anyway, yeah, you'd have to do a bunch of math to make him actually calculated. So if you're not using a top-down view, you're going to have to do that, and this isn't really relevant for you. So like if you look at the side of him, you can see that like right now he's under the ground, and then this time he might be above the ground. So you could do, he happens to be below the ground this time, but sometimes he's above the ground. Like this time. I mean, I guess he landed perfectly that time. But anyway, that's not the point. The point is that if you're not doing a top-down game, you might have to do the actual math to make him land exactly like with a certain number of hops that would actually get him there. But that's not what I'm doing in my game. So there's 3 separate coroutines. The first one is the easiest, so let's go to that one first. Okay, so we're running a forever loop. And in the forever loop, we're running this update emissions command, and then we're waiting for the cycle time. So every 0.2 seconds, the light is going to update. And the higher this number is, the faster it will flash, essentially. So we're using Math Ping Pong. So what's Math Ping Pong? Math Ping Pong is a number between 0 and 1. But when this number goes above 1, so like at the time, which is the input into this, goes above 1, it will go backwards. So let me open Paint, and I'll explain this to you. So we have 0 here, right? So this is the time. I know you love my drawing. So 0, 1, 2. Let's do that. And let's put 1.5 here as well. And so this is the value output. So at 0, it's 0. At 1, it's 1. At 1.5, it would be 0.5 because it goes after 1. The ping pong is like up and down, right? So if it's only a number between 0 and 1, that's the range. So the range is 0 to 1. So at 1.5, it would be back to 0.5. 1.7 would be 0.3. And then at 2, this number will be 0. So as the number counts up, it only goes up to 1, and then it goes downwards after it hits the max value. So the input is the time, and we're dividing the time by the cycle time. So the cycle time, let's get out our calculator. Our time is, let's say our time is 1 second. We're 1 second into this animation happening. We're dividing it by 0.2 because that's our cycle time. So this would be going up 5 times faster. So the speed of this will be faster because our cycle time is higher. Our cycle time is lower because we're using divide. We should probably use multiply. It would be less confusing. So that's how ping pong is working. And then we're getting the colors based on, so we're setting bright, mid, and dim to be just colors. So like the brightness multiplier, which we declared it as a public variable, multiplied by number. So 1 is obviously the brightest, 0.5 would be halfway. And these 2 are white instead of red for the regular color. Oh, sorry, not for the regular color, for this multiplication. So only one of them, the bright one is red and the other 2 are white. And then we're setting the emission color. So inside of the actual light material, there's two. There's the base map and there's the emission. We're only changing the emission. We're not touching the base map. The base map is actually red for all three of them. So that's how the emissions are working. Hopefully that makes sense. I try to explain this as clearly as possible. I think the most challenging thing is probably ping pong. There's also, we're using linear to gamma space for the lighting. I'm not going to explain how that's working just because that's like a pretty heavy topic. You could just Google it and find out how that's working. But okay, so let's take care of the hop routine second because the other one is like the hard one. So this one is a lot easier. Let's take care of the hop routine. So in the hop routine, it's also a forever loop and we're checking if we're moving. And we're checking the horizontal distance between the position and the target position. So horizontal distance is like a method that I wrote that only checks the X and the Z axis. We don't want to check the Y axis because if you make your hop, like your bouncing animation, like your character could be flying off the ground or whatever. And if he's off the ground, we don't want him to, like, we want to do the calculation between 0, like on the ground. It doesn't matter like how high or low he is. It should just be based on like the X and the Z axis. And so then we're using sine to get the vertical position. So again, sine is a number between -1 and 1. So it's very similar to the ping pong that we went through. So the time is 1. The hop frequency is how often this is happening. So the higher the hop frequency, the faster this is going up, and the more the sine wave will happen. And that's him bouncing is just a sine wave. And so then we're multiplying this by the hop height. So that's how high this. Let me just do this in Paint. Hang on, let me do this in Paint. So sine is a number between -1 and 1. So at 0, it's 0. At 1, it's 1. And then at 2, it's 0. And then at 3, it's -1. Okay, so then etc., etc. And then you end up with like this wave. And this is how his hopping is working. So also, so when you multiply the sine wave by another number, because this is a number between -1 and 1, the wave becomes larger. So if we multiply this by 40, for example, I don't know what hop height is, I don't remember, then it would be between -40 and +40. And this wave would just be larger and he'll jump higher and lower based on that, right? So that's how that's working. That's how we're getting the vertical position. Then we're setting the transforms position to be this. We're directly using the transforms position, by the way. You could use the rigid body to do this. It's a lot harder to do that than it is to do it just with the editing the transform position directly won't be affected by like inertia and physics. So I recommend doing it this way. I have it set up so when it touches my player goes flying backwards. But if you actually wanted to interact with the player using regular physics, this will be much, much more challenging. And I'm not going to be explaining that in this video. So if the distance is greater than the hop distance threshold, then it will do this. If it's less, this is where the hop distance threshold comes in. So if it's too close to the target, it will stop bouncing so that it can kind of land and smoothly turn around. So this threshold is pretty small. It's very similar to like the distance threshold, where if it gets too close to it, it's not going to keep bouncing. It will just like stop bouncing for a second while it turns around, and then it will continue bouncing after. So that's the hop routine. Like I said, that's the other easy one. And then we have to go through the hard one. Okay, so this is the most difficult of them to explain. So we've got the final coroutine where we're actually moving between the points. And so again, we have a forever loop with this while statement. While true, this means this will just happen indefinitely. So if you run a coroutine inside of a coroutine, this coroutine will finish before this one starts. And it will just kind of go through the list. So the first one will move to the target position. The second one will turn around. This is called a ternary operator. So if the target position is equal to the point A position, then it will do this. But if this is not true, then it will do this. So the first statement in the ternary operator, which is the question mark, is a true or false. So if this is true, then it will do this. If this is false, then it will do this. That could be a little bit confusing. And then it's going to wait the stop duration, which is 1 second in our case, or 2 seconds or something. And then it's going to change the target position to, again, we're using the same thing. So this is, again, the ternary operator. So if the target position is equal to A, then it will set it to B. if this is false, then it will set it to A. And then we're setting the target position like that before we restart this. So let's go through this. So move to point is very similar, where it's checking the horizontal distance, which remember is only the X and the Z axis. And if it's greater than the distance threshold, then it's going to move. So as long as it's greater than like 0.5 or whatever the number is, it will actually do the movement. This just rotates towards it. And then this is the movement. This is like standard movement stuff. So I'm not really going to go through this. After it's done getting here, it will set the position to be the target position. So it exactly is in the end position. So that way the trigger command up here will be accurate. So when you get there, if you don't do this, it might be very close because the distance threshold is met, but it's not actually there. So this will set the actual position to be actually at the target position, because up here, it's checking if this position is equal to this position, then it's doing this, or otherwise it's doing this. But if it's only within the distance threshold, then it won't be equal. It will be very close, but it won't be equal, and it will be false or true. It will be the opposite of what it's supposed to be. So then we have this is moving thing. I don't know if I'm using this Boolean anymore. I can't remember. Let me just control F for it. Oh, okay. So that's part of the hop routine. So while it's moving, then it will be hopping, but otherwise it won't be. So if it's not moving, it won't be hopping. So that's part of that. And then so after we move to the point, it's going to turn around. So turning around is just standard rotation stuff. It's only going to turn around until the angle is within this threshold of the rotation. So it's going to check if the angles are, because if you try to match these things exactly, especially when you have a rigid body attached to something, they will never exactly match, and it will take, like, your character will spin back and forth and you'll get stuck. So this checks if the rotation is within this certain threshold, which we didn't bother setting this as a editable variable because this is fine. And then as soon as it's within the threshold, then it will, as long as it's not, like, it's above this threshold, then it will continue rotating. And then this just prevents you from getting stuck where you like rotates back and forth to try to get the position. And then after this is done, again, it will set the rotation to be the target rotation to prevent any checks where we're checking if it's rotated all the way. Then I don't think we do that, but we just do that at the end because this is the desired goal. The rotation is supposed to end up being this rotation. Threshold is going to end before it gets there, but we want it to actually fully finish turning before it's done. And then we stop. So this is just like a normal waiting, and then the whole thing happens again. So that's pretty much the entire script. I hope I explained it adequately. Most people probably turn this off right after the variables were explained. If you guys are enjoying this series, make sure you like my video and subscribe to my channel. And hopefully I'll see you guys in the next one.